Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topic of the soil engineering, that is OMC and MDD. And what is OMC, what is MDD, and what is the relation in between OMC and MDD, and what is the use, why it is important. In today's video, I will discuss each and everything about OMC and MDD. So stay tuned until the end to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject, that is OMC and MDD of soil. In the soil engineering or the geotechnical engineering, it is a very important terms that OMC stand for Optimum Moisture Content and MDD stand for Maximum Dry Density. To do any type of work, either a bridge, roads, buildings, whatever, these two factors or these two things you need to know in order to get the structural stability, because all the load is transferred to the soil. So we need to know the soil parameters, so whether the soil can withstand this load or not. And for that, these two factors, this OMC and MDD, is very much important. So please do not skip any part of this video. Stay until the end to get the full information. So first, what is optimum moisture content? In the context of soil compactions, OMC or the optimum moisture content is the water content at which soil attains its maximum dry density, while MDD is the dry density of the soil corresponding to the OMCC. So what is happening whenever we are doing the backfilling or the filling work? We are dumping the soil in layer, then we compact that one. So what is happening when we lay the soil? There is a void or there is a gap in between the soil particles. It may be the water void or it may be the air void. Maximum is the air void. Now we need to remove this air void so that the soil particle come in together or come in very close, so it become a steep layer or the steep, so that the load can be transferred from the structure to the soil. So in order to get that one, what we do? We do the compaction by using the water. What is happening when we are applying external pressure by the vibration of the roller or the roller compaction? What is happening? The air voids from the soil is evaporated and the soil particles is coming together. Then we can say it's achieved the compaction. And at the time of that, we are using water. So if water, why water is using? Because adding water to the soil acts as a lubricant, improving particle rearrangement and reducing air void. That is why we need to add the water into the soil in order to get the full compaction. But now we are adding water, so this again, if water is more, it become a problem. So we need to find out that point when the density of the soil is maximum, so that we can say our compaction has achieved. So how we can see here from this graph, we can easily find out. See, here it is, we are adding water and we are doing the compaction, and after that this is the dry density and water content. So we are increasing the water into the soil and we are doing the compaction, and at time it graph is coming this, and it is increasing the water content, at same time it is increasing the dry density. And after certain time, at a point, if we continue to add the water, what will happen? This dry density is decreased, so our purpose will not solve. That is why we need to find out this point. This point is called, here it is a maximum dry density and it is called optimum moisture content. So in which water percentage the dry density is maximum, that is point called optimum moisture content. Or in the other hand, in the optimum moisture content, what are the dry density of the soil? It's called the maximum dry density. So these two are correlated, because if water is increasing, dry density is also increased. But at this, from the point of the OMC or the optimum moisture content, if we adding more water, the dry density will decrease. So we need to find out this one. So we can calculate this one by IS code. It's given the provision and given the details, how you do the test to find out the OMC and MDD. But this is the things, if we want to achieve the compaction, we need to find out the OMC and the MDD. So this, I think it's clear now. The next part is, see, here it is the context soil, it is the maximum dry density. Now, what is happening when a soil is compacted with less water than OMC? It may not be able to reach its full compaction of the potential. See, here again, in this area, the soil is compacted in water less than the OMC. That's why we are not achieving the maximum dry density. On the other hand, if a soil is compacted with too much water, the water can act as a lubricant, preventing the soil particles from packing tightly and thus reducing the dry density. Again, if we increase the water percentage, it decreases the dry density. So we need to find out the optimum moisture content in order to get the dry density. Why? Because in the optimum moisture content, the dry density is maximum, and in this situation, the compaction is become higher or the maximum. So we need to find out these two in order to get the maximum dry density, or in order to get the compaction proper at the site. And beyond MCC, that I already discussed. And what is maximum dry density? I have already covered. It is the highest dry unit weight of compacted soil at OMC, achieved using standard or modified Proctor on the method. This is the standard method by as per IS code 2720.8. Higher MDD indicates better soil strength and load bearing capacity, because ultimately the structural load will transfer to the soil. So we need to compact the soil so that whatever the load is coming from the structure, it can withstand. So that is why we need to know the optimum moisture content, and we need to know the maximum dry density. And whenever we are doing compaction at the site, we always have the tendency to achieve the OMC and MDD in order to get the proper compaction. So that is why this OMC and MDD is important. The next is why importance, that I already discussed. Still, it is enhanced bearing capacity, ensures soils can support structure, as I discussed earlier, reduces settlement, minimize long-term soil compression. If now there is a voids, there is a air voids in the soil. Now, if the load is coming, what will happen? This soil will compress, and there will be the settlement of the structure. And if the settlement of the structure occurs, structural integrity will be the problem. That is why we need to compact the soil in OMC and to achieve the maximum dry density. If we are unable to achieve that one, when the load will come, again the soil will compress, and then settlement will happen, which will eventually reduce the structural integrity of the building or any structural. Then prevent water seepage, reduces permeability in embankment. It is a very important part, that is reduces water seepage. If the water seepage is continuing inside the structure, again the structural stability will be a problem. So in order to achieve that one, or in order to stop the water seepage, we have to achieve, or we have to do the compaction in the OMC and the MDD. So that is why also it is important. Then improve stability, essential for roads, railways and earth dams, because until and unless we achieve OMC and MDD, whenever we do the compaction, the stability is a problem. So that's why also we need to know what is the OMC and what is the MDD of the soil. So whenever you are doing filling work, first, whenever you get the soil, you need to do the particle size distribution, that is important, then chemical and physical. But the same time, you need to do the OMC and MDD, because for that soil, if you know the OMC and the MDD, and whenever you will do the actual compaction, you can compare and you can say 98% compaction achieved, 98%, 99 or 100%. How? You need to compare with the OMC and MDD of that soil. That is why whenever you start backfilling or filling work, you need to know the OMC and MDD of that particular soil. Otherwise, if you are not well aware about the OMC and MDD, the achievement, the settlement, or the compaction of the soil will not achieve as per the requirement. So this will give a erroneous result and structural stability will be a problem. And guides compaction effects already discussed that determines the required roller type and passes, because whatever the dry density, what is the maximum OMC, that will determine how much load is coming onto that. On that basis, you can plan your roller types and how many passes you require. Although we have the IS code, but it is related that the how much percentage you require, how much load will come, and it will determine the roller type and passes. So these are the importance of OMC and MDD. And testing of OMC and MDD as per IS, that is IS 2720 part 8, I already discussed. But how to do the test of OMC and MDD, it is a separate subject, and in the other video I will discuss that one, how you can perform OMC and MDD at site. The next is coming is the part that is impact and OMC and MDD on soil property and compaction. Why? Because these are the things in the soil engineering or the geotechnical engineering, you need to know why you need to know the OMC and MDD. Its effects on soil strength. Higher MDD, higher shear strength, better load bearing capacity. I will discuss low OMC, dry soil and the poor strength. That means we cannot use that soil for our structural purpose. High OMC, too wet soil, reduced density and stability. So less OMC also not good, and the higher OMC also not the good. We need to find that optimal point where the moisture content is maximum and the dry density is maximum. We need to find out that optimal point in order to get the soil strength. Then effect on permeability, that well compacted soil at OMC reduces permeability, preventing water infiltration, that I already discussed. Then effect on shrinkage and swelling. This is the very important part, that if the shrinkage and swelling is happening, that will affect the structural stability. So expansive soil like clay require precise OMC to avoid cracks on heaving. So whenever we are dealing with the soil, you need to know what type of soil and what is the shrinkage and swelling property, because if the shrinkage and swelling happens, it will ultimately create a problem for the structural stability. And effect on pavement and foundation performance. Incorrect compaction can cause settlement, rutting and heaving in roads. Ensuring compaction at MDD improves durability. So these are all about the OMC and MDD, and what we cover, what is optimum moisture content, what is maximum dry density, what is the correlation in between these two, what is the importance and how to do the test, and what is the impact on OMC and MDD on soil properties. And I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comment, so that from your valuable comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And